Hello guys, welcome to this lecture, and this lecture is a continuous session of functions that we have seen in the last video. Okay, so this is a continuation to the function. So what we have done in the previous one is we have seen what are functions and for what functions are required. We see about monolithic programming and procedural or modular, and we have seen a example, and also have demonstrated the sum of two numbers in the form of function. Now we will just go with parameter passing, because I told you that here passing the value of a comma b and receiving it using x comma y are what called as parameters. This is passing a and b to x and y is called as parameter passing. And I told you one thing, these parameters which are passed in the time of calling a function is called as actual parameters. And while receiving the passed value, these variables are called as formal parameter. And we will first of all start with pass by value, the first kind of parameter passing, pass by value. So in order to make you understand, actually this is call by value, and in order to make you understand what is call by value, I will just write one more I will take one more scenario and we will code for that, and just then I will just tell you. So what we are going to do is we are going to swap two elements. We are going to write a program to swap two elements. Okay, so first of all what we will do is we will just include stdio.h, then followed by a main block, which means manager block. And inside the manager block, what I'm going to do is I'm going to receive two values called a comma b, and I'll be calling an employee, and this employee what is going to do is that he's going to swap the values of a and b, and it is work. The task is to swap, so nothing, no data it is going to return me back. So you can see I'm giving you a and b, you swap the values, that's it, the task is over. The employee need not to return any output to the manager again. There is nothing called output here, so there is no return type, so I can write void means nothing is returned. Okay, so void, and the name of the function is swap, followed by a parenthesis, body part. And inside this parenthesis we need to pass parameters. We need to think of parameters. What is parameters? Parameters are the informations that is required to perform the task. Okay, so what is the task being performed? Swapping. To swap two elements, what you want the two elements which need to be swapped. So what I can do, I can take two variables, and both are integers, right? So I can take two variables called int x and int y, for example, and that's it. Okay, so inside this what I will do, after writing this parameter, two parameters, then we will enter. And what is the procedure to swap two elements? Hope few people could have known, but beginners you might have not known. Okay, so for the beginners I'll just tell you this. Okay, for example, let me take two elements which need to be swapped. For example, let me take this, for example, 1 minute. This block, for example, is x. We can take one more block, and this block will be, for example, like y. So this block is like for y. So this block is having some value called 15. This block is having some value called 10. Suppose let us consider that we need to swap this. Swap means this 15 has to come to this y block and this 10 has to come to this x block. Both these things have to be swapped. What to do? You cannot do x equal to y, because once x is equal to y is done, then automatically x is assigned with the 10. Now you cannot do y equal to x, because the original data in x is actually 15 that was lost. So you cannot do x is equal to y is equal to x. So instead of that, what you can do is, since you're losing the data of x, what I need to do is I need to take a temporary block. I can create a third block. I will show you this. We will create a third block like this. And this block, for example, we can call this block as temp. And what we are doing is that if the original value in x is actually 15, So if I assign y to x, automatically the data on x will be lost. So since if I need not to, if I should not, I should not lose the data. So in order not to lose the data, I'm taking this data before assigning the y value to x. I'm taking this data and temporarily storing it here in this place. And now what I will do, I will just take this y value and I will place it in this x block. So automatically 10 will be. So after storing 10, is it 15 lost? No, 15 is not lost. 15 is temporarily stored in the variable called temp. You can take this value and you can now transfer it to y. Automatically, if you see here, x value 15 gone to y and y values 15 is gone to x. Swapped. So we cannot swap with two. We want an extra variable to swap. Okay, there are a few other ways also, but I'm showing you a common way of swapping. Okay, fine. So now what I will do is I will tell you 3 steps. First of all, temp should be stored with the value. So first of all, take the value of x, store it in temp. Then take the value of y and store it in x. So x is equal to y. Now what you do, take the value of temp and again store it back in y. So the next line is y is equal to temp. So these 3 lines are carried out, then the swapping will take place. So I'll do the same process. Let me take a new temporary variable. Then what I will do, after taking a new temporary variable, now temp is equal to x. The first block value, I will take it and store it in temporary block. Then x will be stored with the value called y. So take the value of y, store it in x. Next, take the value which is there in temp and store it in y now. So y is equal to temp. So this will do actually the what process? Swapping process. Is there anything to be written? No, this is void function. A void function should not return anything. Okay, now let me come to the manager function, main function, and what I will do is I'll just call this swap function, call the swap function, and I'll pass the 2 values which is required by the function, which is a and b. And now what I will do is I'll just initialize some value called 10 and 15 to these 2 variables. After this swap function is called, I'll just print one more value, printf, and I'll just pass %d, %d followed by a comma b. So I'm just printing a comma b and checking whether both these values are swapped or not. Okay, we will just print and we will just check whether this is working or not, because based on that only we will be proceeding further. Okay, this is not problems.c, this is actually the file is different. This is swap.c. so let me execute that, and now let me execute 10 15. A is assigned with 10, b is assigned with 10. Again printing 10 15. No swapping is taking place. Why swapping is not taking place? I'll just tell you the reason. Okay, you know very well that we have 3 different parts like heap, stack, and code section. What will happen once the execution starts from main function? Automatically a main activation area will be created. Shall we create a main activation area? Yes. So here a main activation area will be created like this, and inside activation area what will happen, whatever variables that you have inside your main block will be allocated there. So only 2 blocks a, so block called a is created, block called b is created. What is stored inside this? Here 10 is stored in a block and 15 is stored in the b block. Can you able to see here? Yes. Now what you're doing, you're calling a function called swap of a comma b. Whenever one more function is called, what will happen, a new activation area will be created on top of the existing activation area. So don't delete this activation area, create one more activation area. Okay, create one more activation area, for example like this. So you are creating one more activation area on top of the existing activation area. And how many variables are there inside that activation area? There are totally 3 variables, x, y, and temp. So what you do, you create 3 blocks inside. What is the 3 blocks? X block is created, then y block is created, then followed by temp block is created. And now what will happen? I think you're passing the values of a comma b, which means the value of a is sent to x, value of b is sent to y. So what will happen now? What is the value of A? 10. So 10 is sent to X. So X is now stored with 10. Similarly, the value of B is sent to Y, which is 15. Now after doing this, what will happen? Temp, a new variable was created, and temp is equal to X. What is there in X? 10. So now store 10 in your temp. So 10 is now stored because of the line temp is equal to X. I'm taking the X value 10 and storing it in temp. Okay, fine. What is next one? X is equal to Y. So value Y is taken and stored in X. So what is the value of Y? 15. So 15 is now stored in X. Now what is the next line? Next line is Y is equal to temp. What is there in temp? Now temp is having 10. So take the 10 and store it here in Y. Now if you see, the values are swapped. The values are swapped. And tell me one thing. If I change the value of X, will it affect A? No, definitely not, because this is a different activation area. This is a different activation area. X is a different memory block having different access. A is a different memory block having different access, a different address. So if you do any change on X, it's not going to change the value of A. So what next will happen? The last curly braces, ninth line will be executed. Once curly brace is executed, what will happen? The corresponding activation area has to be deleted. Am I right? So it is deleted. Now again the flow will come back to the, I told you that the topmost activation area will be the active one. Now what is the topmost activation area? Main activation area. Okay, so now when I come back again, if you see, the A value and B value is not changed. A values and B values are not changed. Okay, A value and B value is not changed. Okay, so what I will tell you is that this is call by value. What you have done is call by value, and here what you have done is also call by value. Okay, so when call by value is happening, what will take is that, for example, let me take this parameter. Let me define that this parameter is formal parameter. Formal parameter. And what is this parameter? Here, calling place. This is called as actual parameter. Actual parameter. And now how I'm going to define call by value is, a pass by value is, whenever you change your formal parameter, you mean X and Y, whenever you make any changes to the formal parameter, this will not affect your actual parameter. Whenever you do changes to a formal parameter, it will not affect your actual parameter, which is what called as call by value, which is what generally defined as call by value. What is pass by value? If the formal parameters are changed, then the actual parameters will not be changed. So if the scenario, based on the scenario only, you have to choose either pass by value or pass by address or pass by reference. Now tell me, is swapping is suitable with pass by value? No, swapping function is not suitable with it cannot be carried out with call by value, because for swapping what has to take place is, whenever the changes is happening here, that change has to reflect here also. So whenever changes is happening to formal parameter, the actual parameter also has to be changed here in the swapping concept. So here we cannot use pass by value, because pass by value can be used in places where the change in formal parameter will not affect actual parameter. So for swapping purpose, you cannot prefer pass by value. Okay, then what can be referred here? Call by address can be possible here. Okay, call by value can be. So before before demonstrating call by value, sorry, call by address, pass by address, I'll show you the line by line execution of this same program, and we will see the changing for the change that we do in the formal parameter is not affecting the actual parameter. We will just prove it. Okay, fine. So I'll just go with the line by line execution. Yes, so the execution starts and the activation area for main is created, and I'm having only two blocks A and B, and if 12th line is executed, 10 and 15 is assigned to A and B. And now there is a function called swap of AB, so I'm calling the new function. So I suddenly enter into the scope of swap. Now what happens, inside one more activation area called swap is created on top of the existing activation area called as main. And inside swap, if you see, you have different, see, inside main you're having A and B, and inside swap you're having temp X and Y. So now what is happening? your x and y parameter are passing the value and you're receiving it. So x and y is receiving a value, it is passing a value, and it, see here it is passing a value, here it is receiving a value. That is why it is called by value. And now what I'm doing is temp is equal to x, so x 10 value will be stored in temp. You can see x value 10 is stored in temp. Then x is equal to y. What is x? 10. That 10 value will be now transferred to, actually sorry, temp is equal to x already. Okay, temp, now x is equal to y means x value 10 is now transferred to, sorry, y value 15 is now transferred to x. Y, x is equal to y means y value is just transferred to x, so y value 15 is transferred to x, so 15 is transferred to x, so x will change into 15. Yes. What's the last line? Temp will be transferred to y. So what is temp holding? 10. So 10 will be sent back to y such that it is swapped. But if you can you able to see here, now the changes is made. 10 and 15 are now swapped. Now let me go to the main function and check. Is there any changes here with the main activation area value? No. Here A and B are not changing. It is having the same value only. So this is actual parameter, sorry, this is formal parameter, and this is actual parameter, because this is inside the calling function. Okay, this is inside the main function. So these two are called as actual parameter. A and B are called as actual parameter, and swap x y is called as formal parameter. So now I have changed the formal parameter, but it is not affecting my actual parameter. This is what called as call by value. And now once this last line is executed, what will happen? Then the activation area of swap will be deleted from this place, and the flow will go to 14th line. And 14th line, what will happen? The unchanged AB will be printed. So no swapping will take place. Only 10 and 15 again will be printed back. Okay, so this is what call by value. So whenever you do changes in formal parameter, it will not affect the actual parameter. This is what call by pass by value is all about. Now I will come to the case of call by, see, you remember very well, whenever, see here also A and B is having a separate memory block. Here this parameter is also having a different memory block. Okay, both are different actually. Okay, that you should always remember. Now I will change this swap into pass by reference. I'm going to change it to pass by, sorry, not reference, pass by reference is different. Now I'm doing pass by address. I'll come to reference later, but now I'll just show you pass by address. Pass by address. Remember one thing. If I have two activation area, this variable on one variables on one activation area cannot be accessed in the other activation area directly. I'll tell you, similar to the concept that I have explained you in pointer, right? Whatever is there in heap cannot be directly accessed here in stack. Similarly, whatever is inside add activation area will not be accessed, cannot be accessed in main activation area directly, because this is a separate room. Add activation area is a separate room, main activation area is a separate room. So you cannot directly access the data from other activation area inside another activation area. So if two activation area called main and add is there, then the variable which belongs to add activation area cannot be accessed inside main activation area directly. Similarly, this is applicable for vice versa, it is applicable for main function also. Okay, fine. So now let me come here and see, at any cost that rule cannot be violated. Which rule? The variables in one activation area cannot be accessed directly in the other activation area. This rule cannot be violated at any place, any situation. Okay, fine. So now the next thing that I will show you is call by address. What is call by address? Here you are passing the value called 10. Instead of passing the value called 10, what you are going to do is you are going to pass the address of this variable A. Instead of passing the value of A, you are going to pass the address of A. Here also similar for B also. So how to pass the address? If I need to pass the address, I should not pass A, I should be passing ampersand A, because ampersand A will give you, this ampersand symbol will give you the address of the variable A. So don't pass value, pass address. So address means ampersand variable. So similarly ampersand B. So data variable will be capable of storing data. If I'm sending address, which variable will be able to store address? I told you already, pointers are called as address variable, which is capable of storing the address. A normal data variable cannot store address. So now you are sending a address. So if I need to receive the address, what I need to have here? I cannot have a normal data variable. I should be having a pointer variable to receive the address. Okay, so I will change this into star x and star y. Okay, so instead of passing the value, I'm passing the address. Instead of receiving the value by data variable, now we are receiving the address by pointer variables. Okay, now you know very well that x means it refers to the address of a x. So I'll just show you here. For example, the same blocks, these blocks I will use for just make you understand. Okay, let me consider that only one example I will take. This is a block called a. This is a block called a, which is there in the main block. Okay, let me consider that this is a block called x, which is there in swap block, swap function. Now what you are doing, you are not passing the value here, you are passing the address. So what will happen now? Address of a is, for example, 0x1234. The address of a is 0x1234 hexadecimal. So you are now passing the address. So what will be stored here in the pointer variable called x? 0x1234 will be stored. So if you just simply refer to x, what it will actually give you back? It will give you back the value which is stored inside. What is the value stored inside? It is the address of another variable. So when you simply give x, what it is referring to? It is referring to this address. But if you want to dereference it, dereference means if you want to refer to the value in the memory block 0x1234, then I need to give a star operator in front of the variable. So if you give x, it will give you 0x1234. If you give star x, it will give you 10, which is stored in 0x1234. So now tell me, are we going to swap? Are we going to swap the address? Are we going to swap the address? Or are we going to swap the value? We are going to swap the value. If you want to get the value, what we need to use? We need to use star. We are not going to swap address. We are going to swap the value which is in the address. So in here you cannot use x. You have to use star x. Okay. So wherever x and y are used, change it to star x and star y. I will not tell that always it has to be used with star. No, whenever you want to access the value, then go with star operator. If you are not, if you don't want to access the value, you want to access only the address, then you can simply write x or y. So this also has to be changed to ampersand means star y. Now what will happen? If you see what x is holding, okay, let me see. Let me show you the exact scenario here. For better understanding, I'll just give you. Okay, for example, what I will do is that here I'll just take one more block. This is actually the element called b in the main block. For example, let me consider that this is a block b. This is called as block b, variable b, which is also there in main function. Similarly, I will take one more corresponding block which is called as y, which is there in the swap block, which is there in the swap block. Okay, and this block will be having a variable called, this is named as y, and for example, this is having an address called 0x1234. Similarly, this b will be having the address called 0x2345. And now you are passing the address of a to x, so 0x123 is stored here. You are similarly passing the address of b, so 0x2345 will be stored here. Now I want to swap these two elements. What elements? The elements which is stored in a and b I need to swap. Not these two addresses I need to swap between x and y. So if I simply give x is equal to, if I just simply give temp is equal to x and x is equal to y and y is equal to temp, what will happen? These two address will be swapped. This 0x2345 will go here and 0x1234 will come here. Only the referencing will change. Instead of x referring to a, y will start referring to a. only those thing will happen. The values will not be swapped between A and B. So if you want to swap, what do you need to do? You have to not swap these two things. You have to go there and you need to swap these values. So if you simply give x, what it is referred to, it is referred to the 0x1234. But if you give star x, it is referring to this 10. So what you have to do, you have to go to this memory block and you have to take the value of 10 and you have to shift it to 15. You have to take 15 and you have to place it here. So you have to swap it by using star x and star y, not using x and y. Okay, and now the same, what we will do is the same code, we have changed it to pass by address. Now we will just execute and check whether this is working or not. Whether this is working or not. Swap. Yes, previously it was printing 1015, now it is printing 1510, which means that A is now printing 15, B is printing 10, which means the value have been swapped. Values have been swapped. I'll just show you the line by line process also on the left side to make you understand it better. Okay, so now if you see, a main activation area is created, and inside main activation area I'm having two memory block called A and B. If this line 12 is executed, then the value 10 and 15 is assigned to A and B. Now this 13 have to be called, 13th line, that's a function call. So what will happen, a new activation area will be created, and can you able to see here, now x is storing the address of actually A, and it is also storing the y is storing the address of B. Can you able to see this hexadecimal address? It is not having any value, it is storing a address, as I was demonstrating here. X is I'm showing with that, it is storing address, right? Y is also storing address. Similarly, you can able to see here, X is, because you are passing the address of A, that address of A is received by X, and X is storing the address. Let me expand it and I show you. What is expand? Expand means now this address is referred to. So if X means this address, star X means it is 10. Can you able to relate now? Y means it is address, star Y means it is equal to 15 now. So now temp is equal to star X. What will happen? Star X means 10. 10 will be taken and it will be placed at temp. So now what will happen actually? This 10 is now stored in temp. Can you able to see here? Yes. Now star X is equal to star Y. What will happen? Star Y is having 15. That will be taken and stored here in star X. So now star X will be having 15. Yes. Now I will just come to the main block and I will check, because what X is referring to, X is referring to the address of A. So now whatever change that I'm doing with this X has to actually affect it, because we are changing it in the memory block. We are not changing it in the variable, we are changing it in the memory block itself. So we'll just go to main function and check whether A is now having 15 or not. Yes, can you able to see A is having 15? A is having 15. So whatever changes I'm doing here, that changes are being reflected here also. Okay, fine. So I'll go back there itself, we will start. Okay, seventh line, we'll continue. Okay, seventh line, what is here? Star Y is equal to temp. So what will happen? So star Y is equal to temp. What will happen? Temp is having 10. That 10 will be taken and it will be stored here instead of star Y. What is star Y? It is referred to B. So whatever change I'm doing, that change will happen here in the B itself. So what will happen? Now star Y will be having 10. So similarly, if you go and check in main, your B is also changed. So swapped. Now what will happen? The last line of swap is executed, so the activation area will be deleted. Even though this X and Y is deleted, using X and Y already I have swapped A and B, which is there in main function, so no issues in deleting it. So when this function is executed, activation area is deleted for your main function. Now I will print A and B. What is A and B? 15 and 10, it is swapped. Okay, then that's it, all these are deleted. So how I can define pass by value, how I defined it in pass by value, what I was defining, whatever changes that I do to the formal parameter will not affect my actual parameter. This is what the definition of pass by value. Now coming to pass by address, whatever changes we do to the formal parameters, that changes will affect the actual parameter. So pass by address has to be used in situation where the change in formal parameter has to really affect the actual parameter. Actually swapping requires that, because swapping requires a effect here in the main function also. So that we are using the pass by address. So when you have to use pass by value, whenever the change in formal parameter should not affect your actual parameter. When you have to go with pass by address, whenever changing formal parameter has to really affect the actual parameter, then you have to go with pass by address. Okay, so actually this session is going for the past 30 minutes. Okay, fine. Okay, so next what I will do is I'll just stop the session here. I think so we started the session by 11 o'clock and now it will be like 11:30, around 11:30. The next session we will start by 11:45, and that session I will just teach you about one more type of parameter passing, which is called as pass by reference. And I'll tell you one thing, pass by reference is not available in C programming. It is available only in C++ language. Okay, people confuse it. Okay, C++ is having like data variable, like address variable called pointer. There is one more type of variable called reference variable, which is there in C++. So why I'm teaching you that call by reference is you should not confuse between call by address and call by reference. Pass by address is different, pass by reference is different. So I will just demonstrate you the difference actually. Okay, and the background processing also I will explain you. Okay, so that we will do in the next lecture, and this is it for this lecture. Okay, so thank you. So hope you understand this pass by value, pass by address difference in a better way. Okay, so thank you.